Hello. Today we are going to examine facilities with HACCP applications and their case studies, demonstrating changes in order to learn more about practical management methods of HACCP. HACCP as a system possesses two functions. It analyzes the situations where hazards may exist at the raw material stage of food or during a manufacturing process, and this system prevents causes of hazard factors in advance. In other words, it is a prevention system for food safety management to provide safe and sanitary food to customers as well as to prevent any hazard. To put it simply, it is management that is designed to find, prevent, and control causes of hazards. Controlling hazards in advance surely increases safety level with no doubt. HACCP employs a systematic operation method that is composed of 12 steps with 7 principles, 5 preliminary steps and 7 main steps. 7 principles and 12 steps is a process that builds a complete management system. So, from now on, we will be looking into essential factors in 7 principles and 12 steps that you must learn.
The first step to develop HACCP plan is to assemble a team that will play a leading role in HACCP plan development. HACCP team directs all works related to HACCP system operation. In detail, the team is in charge of prerequisite program development, HACCP system development and examination, system improvement and operation, coordination with another team, development plan research for HACCP, and so on. The next step is to write product descriptions and identify its intended use. The product sheets will be used as materials to confirm any hazard related to the product and to assess the risk of confirmed hazards. They also become important data to set limits and critical control points in respect to the product's properties. The product descriptions must include necessary items such as product name, product type, and properties, report date of product manufacturer, writer's name and reporting date, mixing ratio, and manufacture method of properties, manufacture unit, dimensions of finished product, precautions on storage and distribution, intended use and distribution period, packaging method, and the quality of the materials, indications, etc. Each facility is supposed to make an appropriate form of product descriptions that is most suitable for the facility. For end users or customers, confirming the intended use of a product shall be conducted, and especially, it needs extra attention when manufacturing foods for vulnerable consumers, such as children, pregnant women, the elderly, etc. As the fourth preliminary step, HACCP team studies all processing steps, from raw material receipt through to finished product distribution, which are directly under the control of the manufacturing facility to make the process flow diagram and to write main manufacturing conditions for each processing step. While making the process flow diagram, it will be a good idea to make a clear table that shows manufacturing methods for each processing step in detail. A process flow diagram is greatly helpful to figure out any hazard that might occur during the process. A floor plan of the manufacturing facility can also be very helpful. A floor plan is a drawing that indicates facility name and section names reflecting the characteristics of each manufacturing facility. Using this floor plan, it is possible to understand the risk of cross-contamination caused by workers, logistics, water drainage, ventilation, etc., as well as to establish preventative measures. Finally, HACCP team verifies that the prepared process flow diagram and floor plan are identical to the actual working process by comparing them in person on the facility site. This step is confirmation step to see if the process flow diagram and the facility floor plan are written suitably in accordance with the working environment. When accurate process flow diagram and facility floor plan are all prepared, it is considered ready to fully implement HACCP plans.
The first principle for developing a HACCP plan is a hazard analysis. A hazard analysis is conducted by HACCP team, and it is divided into two criteria. One criterion is conducting a hazard analysis for each of raw materials or ingredients indicated in the product description, and the other criterion is conducting a hazardous analysis for each of processing steps indicated in the process flow diagram. During the hazard analysis, the list of potential hazards should be written and in flow path of each hazard, and its control measures should be studied.
Steps of analyzing hazards are as follows. Firstly, understand potential hazards and why they occur. Secondly, evaluate the severity of identified potential hazards. The evaluation is conducted based on the severity and likely occurrence of hazards in accordance with absolute criteria. Thirdly, address preventative measures for identified hazards and make an analysis table for the hazards. The information on identified hazards can be used in various ways, such as reevaluation of HACCP plan, establishing improvement measures for limit deviation, seeking countermeasures for unpredicted hazards, etc. Being unable to conduct an accurate hazard analysis hinders the establishment of effective HACCP plan. Therefore, a hazard analysis is a very important step that needs to be done with rigor. The second principle of HACCP is to determine critical control points. A critical control point means important stage, step, or process that secures food safety by preventing, controlling a food safety hazard, or reducing it to an acceptable level through application of accreditation criteria for food safety management. Examples of the critical control point in food manufacturing process are as follows. However, even when an identical product is being manufactured, working environment can be different by manufacturing equipment and so on. Thus, the examples of critical control point can also be changed.
We just looked into the critical control points, then what is a critical limit? A critical limit is standards that determine whether or not hazards are being controlled within an acceptable range.
Critical limits should be indicated using easily recognizable figures or particular figures, which allow a visual observation or a simple measuring process on site. For example, items requiring critical limits are lowest temperature in the center of a product when heating up, minimum time to freeze a product to a certain temperature, size of any possible metal piece, foreign substance, etc. Establishing critical limits is a procedure that prepares production standards to produce safe products.
The fourth principle is to establish a monitoring system which effectively manages critical control points. Monitoring is to observe and measure using the human resource or mechanical method in an effort to manage the process of critical control points stably within critical limits.
Monitoring should enable consecutive management, and if not possible, monitoring cycles should be set. A person who is in charge of monitoring shall be sufficiently educated, trained technically so that he or she properly checks monitoring items in the critical control point with appropriate monitoring method. Also, it is better to record the exact figures from actual monitoring rather than to simply record yes or no, or accepted, not accepted. The fundamental objective of HACCP is to find out and modify problems before food hazards occur. That being so, it is important to be well informed of corrective actions in advance in order to take countermeasure in a prompt manner when things go wrong. To easily find corrective actions, a checklist, as shown here, can come in handy.
Verification means checking if HACCP management plan is well established and maintained properly. Verification procedures often divide into two aspects: validation and feasibility.
Verification for validation is to verify that established HACCP management plan and prerequisite management standards, including hazard analysis, determination of critical control points, the establishment of critical limits, etc., are valid. In this procedure, scientific verifications, such as standard inspection for end product, cleaning, disinfection, etc., are conducted. Verification for feasibility is to verify that established HACCP management plans and prerequisite management standards, including hazard analysis, determination of critical control points, the establishment of critical limits, etc., are properly maintained on site. Confirming documents, such as monitoring records or a status check sheet, and checking whether or not management plans are implemented on site are ways to verify feasibility.
Lastly, the seventh principle of HACCP is to establish a record-keeping procedure that documents HACCP system. Record keeping is essential to HACCP system, and without record keeping, HACCP system is inefficient and lacks grounds to operate the system. Therefore, detailed records about the operation of HACCP plan must be present. The best record keeping is a simple, comprehensive form, and it allows readers to understand necessary records easily. Facilities need to create the simplest and easiest record form, considering recording time and location in accordance with the facility's environment.
Documents related to HACCP system operation are as follows. These documents play an important role in providing that the facility complies with HACCP management plans before distributing products.
So far, we have learned 5 preliminary steps and HACCP's 7 principles. Then, shall we look into actual facilities that implemented HACCP and how they have changed?
In this facility, as you can see, they made the process flow diagrams for each product they produce. After making process flow diagrams, it becomes possible to quickly notice where is at risk of having cross-contamination. Also, with a facility floor plan, they control any potential cross-contamination during transportation. Based on the facility floor plan, they see the likely occurrence of cross-contamination caused by logistics, drainage, ventilation, etc., and establish preventative measures. Also, a facility layout showing locations of equipment in the facility allows more systematic and thorough management. Such process flow diagram and floor plan are very helpful to understand hazards, cross-contamination, and any potential hazard, such as secondary contamination or its growth in all processing steps, from raw material receipt through to finished product distribution. The next shows how corrective actions were implemented after realizing critical control points that are at risk of hazard occurrence. This facility uses a mincer for meat processing. Using a mincer contains the risk of hazard that metal foreign substances can get into food. So, in order to prevent metal foreign substances from mixing with food, they installed and have operated a metal detector. Also, they do not neglect to install SOP about the operation of the equipment and to keep a record of use attentively. Furthermore, since this facility handles meat, it is most important to handle raw materials at the proper temperature. This facility designates critical control points for storing raw meat and finished products, and temperature management, and also thoroughly keeps the temperature within 2 to 5 degrees below zero, which is considered proper temperature. The critical control point for this ham manufacturing facility is sterilization process. The facility takes measures to maintain that core temperature of smoked hams is over 75 degrees, and the surface temperature of the hams during secondary sterilization is 75 degrees plus, -2. The next facility is a beverage manufacturer. The most critical control points in beverage manufacturing are sterilization, filtration, and bottle washing. This facility introduces automation system for an important process. The most important thing in sterilization is temperature. This process automatically shuts down if the temperature does not meet the critical limit. For this, it is equipped with temperature measurement devices. And also, all workers in the facility can check the temperature. For filtration process, which is another critical control point, strainer condition is frequently checked before and after the operation, and also it is maintained with thorough record keeping. This facility attaches rubber pads on bottom sides of the entrance to fill the gaps for sealing meticulously. If an access hole in the ceiling is open or there is a hole in the ceiling, it carries a high risk of foreign substances falling down or insect getting inside. It shows that neat finishing touches prevent such risks. There are many cases that the ceiling in the facility has moisture condensations generated from a heating device or refrigerating device. When such moisture condensations drop on a product, it might cause contamination. In order to prevent that, this facility installs a vent and a thermostat on the section where moisture condensations are generated. Also, the facility floor with cracks is repaired using a water-resistant material to prevent mold and foreign substances. A drain on a facility is a perfect place to generate contamination. This facility directly connects the drain with drain pipes to minimize water being exposed to the facility floor. Also, they clean the drain regularly to prevent waste from piling up and make sure to install a cover for the drain to prevent cross-contamination caused by wastes. To prevent cross-contamination generated in a washroom, they remove hand towels and install a hand dryer instead. Also, to strengthen personal hygiene, they place hand sanitizers. They additionally install a hand disinfection device on the outside of the washroom door, which will meticulously prevent cross-contamination caused by the washroom knobs. Now, let's take a look at the dressing room. Since a dressing room is very private, it might not have sufficient maintenance. Workers of this facility stores a disinfected overgarment in the upper side of a locker and everyday wears in the lower side of the locker, which prevents cross-contamination caused while changing clothes. Also, to make cleaning easier, the upper side of the locker has a slope. In a shoe shelf, indoor work shoes and outdoor shoes are separately placed to prevent cross-contamination. Why don't we take a look at the entrance connecting to the facility? They put up a notice about standards for proper clothing. Also, it is well equipped with sanitary devices for hand washing, drying, disinfecting. It has a separate section to wash the work shoes for removing and preventing potential foreign substances. Lastly, it installs a footstool for disinfection to control any possible inflow of pathogens. It shows well-built hygiene system that leads to the facility, which is a clean area. Successful settlement of HACCP system requires each worker who produces products to observe hygienic measures above all. Each worker shall wear disinfected overgarment, mask, headwear, hygiene shoes, apron, etc., appropriately in compliance with proper clothing regulations for each section. Also, any unrelated personal belongings, such as cell phone, watch, padlock, etc., should not be allowed in the facility. Separate lockers for personal belongings shall be installed and used. Any tool that is used to manufacture food is considered to be a critical control point too. This facility self-produced the storage box for knives in order to prevent contamination caused by foreign substances and germs dropped on the products. The storage box also makes it easier to store and maintain blades separately. Furthermore, separate storage of gloves, aprons, arm sleeves, frequently used on site, prevent cross-contamination. Likewise, clean area and general area use separate cleaning tools in an effort to pay more attention to the hygiene of the clean area. Shall we take a look at the facility? When equipment used in the facility directly touches the floor, it is possible to have hygiene issues, such as foreign substances getting into the products. So this facility eliminates potential contamination in advance by installing all equipment at a certain distance from the floor and walls. When items are touching the floor, they're exposed to various types of contamination. They solve the issue quite easily by making floor boxes when storing items. Also, covering the equipment with wrap or vinyl to prevent foreign substances, such as dirt, from piling up. It is also important to manage the moving lines well in the facility to reduce cross-contamination caused by movements. This facility uses a tape that has the different color from the door in order to segregate a moving line for workers from a moving line for raw materials. Using tapes, it shows a simple solution that indicates moving directions and divides sections. If wastes are not stored properly, they cause contamination, such as stench, vermin, leachate generation, etc. Waste must be stored and sealed in a separate container, and designating a separate section to store waste for special attention to the waste is highly recommended. Also, it is necessary to write detailed records on waste type, generated amount, treated amount, and how the wastes were treated. Temperature control systems for refrigerator and freezer are the ones that food manufacturing facilities need to put so much effort to properly maintain. This facility installs temperature criteria (SOP) for each refrigeration equipment and records temperature maintenance logs every hour. When loading items in the refrigeration equipment, they use pallets to prevent raw materials from touching the ground and manages the materials by thorough record keeping on dates and times for first in, first out. When the facility uses underground water, it is required to take measures for disinfection, such as chlorination, UV sterilization, micro-installation, etc. In case of using a separate water tank, it is required to clean the tank regularly and to strengthen security for the water tank facility in an effort to block any inflow of foreign substances. Vermin and rodents are great threats to food hygiene. To prevent them, many facilities employ insect control methods, such as traps, flypaper, etc. This facility analyzes the amount of captured insects and operates a countermeasure device based on the analysis. Also, this facility shows how they control and prevent the inflow of potential hazards by installing filers in vents and drain pipes. If any piece of the broken lamp in the facility gets into products, isn't it obvious that it would become a great hazard? This facility installs a shatterproof cover to prepare for any potential accident. According to HACCP standards, illumination of the working section, where visual inspection is an important step, shall be above 540 lux at least. This facility creates a separate check table for illumination for maintenance purpose.
So far, we have learned about 7 principles and 12 steps that constitute HACCP operation system, as well as several facilities operating hygienically and safely through the applications of HACCP program. With today's lectures, hopefully you are encouraged to participate in HACCP actively and to meet your consumers with great products and pride. Thank you.